We are ready for the exercises for lesson 4.1, which was average rates of change. The ones I will work over are here from OpenStax Precalculus 2E. You should try them, then come back to this video. We will discuss these solutions. We begin with 17 from section 1.3. We want to estimate the average rate of change of this function from x equals 2 to x equals 5, and we're given a graph. So first, perhaps I will mark the points on the graph. So here would be 2 comma f of 2, and then we also want 5 comma f of 5. Let's write the points here. This looks like 5 comma 7 approximately, and this one looks like 2 comma 3. So what we want for average rate of change, this would be change in the function divided by change in x. This would be f of 5 minus f of 2 divided by 5 minus 2. But we see, looking at the graph, f of 5 is 7 and f of 2 is 3. We have 7 minus 3 over 5 minus 2. This gives us 4 divided by 3. So the average rate of change here, at least an estimation, is 4 over 3. Now, let me move this coordinate labeling here, and I will go ahead and draw the secant line. This is what we were discussing in the lesson. The secant line for this function between x equals 2 and x equals 5, this would just connect these 2 points. This secant line has slope 4 over 3. This is just connecting this definition and language of our lesson to this problem. 29, we're given h of x. We want the average rate of change of h of x from minus 2 to 4. This would be h of 4 minus h of minus 2, and then divided by 4 minus 2. So as we did in the lesson, we can come to the side, calculate h of 4. This would be 5 minus 2 times 4 squared. 4 squared is 16. So we have 5 minus 32. This is negative 27. And then h of negative 2. This is 5 minus 2 times minus 2 squared, which is 4. So we have 5 minus 8. This is negative 3. So now we can go back to our fraction. We have minus 27 minus 3, and then divided by, well, 4 minus 2 is 4 plus 2, or 6. So we get minus 24 divided by 6. This average rate of change is negative 4. Number 30, we will have q of x is x cubed. We want the average rate of change between minus 4 and 2. This will be q of 2 minus q of minus 4, and then we divide by 2 minus 4. Well, q of 2, this is 2 cubed, which is 8. Q of minus 4, this is minus 4 cubed. This is negative 64. And so we have 8 minus 64, and then divided by, well, 2 minus 4 is positive 6. You see, this is 72 over 6, which is 12. This was number 30. Now, we have a few more here with average rates of change. 32, we want the average rate of change of 1 over x from x equals 1 to x equals 3. If I call this, say, f of x is 1 over x, then we would want f of 3 minus f of 1 and divided by 3 minus 1. Maybe with this one, I won't come to the side and calculate because the function is just 1 over x. So f of 3 is 1 over 3, and f of 1 is 1 over 1. Now, if I get a common denominator here, you see it would be 3, or you can just think 1/3 minus 1 is -2/3. So I have -2/3 divided by 2. This is -1/3. You could take this, which is 2/1, invert and multiply. We would have -2/3 times 1/2. You see, this is -1/3. But I will just underline this. My final answer is -1/3 here. 33 looks complicated, but first let's write the formula. We want the average rate of change of P of t from -3 to 1. So this would be P of 1 minus P of -3, and then divided by 1 minus -3. Well, we will come to the side, definitely I think on this one. Let's calculate P of 1. And we will also calculate P of -3. P of 1, well, we have 1 minus 4, we have 1 plus 1, and then we divide by 1 plus 3. Altogether, you see this is -3 times 2 divided by 4. We almost have this. This is just -3/2. Now, P of -3. This will be similar in terms of, we'll calculate it in a few steps. So -3 squared is 9. So we have 9 minus 4. We have -3 plus 1. And then we have 9 plus 3. So what do we have here? Well, 9 minus 4 is 5. We have 5 times -2, and then divided by 9 plus 3, which is 12. You see, this is -10/12, or -5/6. But this is -5/6. Now I'm ready to go back into this part. P of 1 is -3/2, and then I have a -5/6, and then divided by 1 plus 3, which is 4. So let's get a common denominator in my numerator. I like this example because we have to be really careful with fractions, but it's a great exercise for us. Common denominator in my numerator would be 6. So I can multiply this term by 3/3, and I will have -9/6. And the second one, you see I have negative, it's a plus. 5/6, and then all over 4. -9 plus 5 is -4. So I have a -4/6. And then I will invert and multiply. If you want to think about it that way, we will be multiplying by 1/4. So I have a 1/4. And now you see we have the final answer. The average rate of change of P of t on the interval -3 to 1 is -1/6. This was a great exercise. The last question, we want to find the average rate of change between these 2 points. Really, it's a slope. So another way to say that is find the slope of a line containing these 2 points, which is what we were doing the very first lesson of this ramp up. But we also know if there's, say, some function that connects those 2 points, the average rate of change on the interval -4 to -2 would be the slope of the secant line. Okay, so maybe just because this one has a smaller x, I'll call this point x1, y1, and I'll call this point x2, y2. Although it really doesn't matter which way I label the points, we would have the same slope. So what we want here is change in y divided by change in x. And we get, maybe I will do this in 2 steps, y2 minus y1 divided by x2 minus x1, 0 minus 5 divided by -2 minus 4. So this gives me -5 over, well, -2 plus 4 is +2. So the average rate of change here is -5/2. This was our last example in the exercises for lesson 4.1. Thank you so much.